industry standard for soldering, which you'll have to meet when you finally start doing your soldering lab. Currently, we're going to provide. We've got some of these robot kits. They're escape robots. They're really cute. They're not technically they're not robots because they're not reprogrammable, but they're really, really neat. They use ultraviolet or infrared light to detect surfaces, and then they make decisions on which direction they're going to turn, which is really neat. What we'll do is look at some of the rules for soldering. A lot of people think they know how to solder, but they don't. And so what we're going to do is, I'm going to demonstrate tonight, and then at the end of class, y'all will start soldering your kit together. And like I said, you will not be able to solder away from here, but you'll put it. I'll go get one that puts together. This is an electromechanical device, which works out real well in this class, because not only are you doing soldering, but you're also assemble a gear train. So it's got a gear train on it. It's got two motors, and then of course it gears it down so it can so it goes from little to big. So it's going to get slow it down, but it will get more torque, right? Yeah. And it's pretty neat. It uses infrared, I think. In fact, I know it is because the transistor is an infrared transistor. First of all, the wire must be properly stripped and tinned. What's tinning? When we coat something with solder. So anything that we coat with solder, we refer to that as tinning. So like when we are going to put a stranded conductor, and I get some stranded conductors. If we're going to put a stranded conductor around a terminal, then we usually solder it and we tin it. We tin it first, and all that's in this PowerPoint here that we'll look at. Avoid touching the exposed conductor. The maximum number of damaged strands in the conductor is given on the next slide. After tinning, the wetting of the tin wire must penetrate the inner surface. So wetting was a term that we looked last time in the class. And what's wetting? Not your bed. What's wetting? I know it. What's wetting? Wetting. That's tinning. Wetting is when the molecules, the surface molecules of the metals that you are soldering together bind with the molecules of the solder. So wetting is something that you, over time, you learn when you've got good wetting. If you don't have good wetting, then you've got what we refer to as a cold solder. So anything that don't have good wetting gives up with something we refer to as a cold solder. And what usually that means is, it means that one of your metals didn't get up to the right temperature. But also it could mean that there's some type of material or oxide or something on what you're trying to get wetting, and you didn't clean it off, or your flux didn't clean it off. Wicking of the solder. Wicking, y'all understand what wicking is? Huh? Not wicking. Well, if you understand what a candle wick is, if you've got a kerosene lamp, if you've got a kerosene heater, it's got what we call a wick. So wick is when a fluid is pulled into something, right? You understand? Yeah. We call that wicking. Or away from it. So one of the methods that we do to take solder out, to desolder. So if you learn how to solder, after a while you'll learn how to desolder. And desoldering is just about as important as soldering. So we got two methods that we can desolder. One, we can use a solder vac, or the other we can use what we call solder wick. So solder wick is just braided copper wire And when you put it on the solder, it does what? It wicks up into it. It absorbs or moves into the wick. So that's one way that we can do it. So if we deal with stranded wire has a tendency to act like a wick. Wicking of solder under insulation should be avoided. So what happens is you put too much solder and it wicks and gets back up under your insulation. That's not good. Because solder is melted liquid, right, and it degrades the integrity of the insulation. And also it reduces the flexibility of the conductor. So we got two types of conductors. We have what we call solid conductors and we have stranded conductors. And what is the advantage of each? I mean, if there wasn't an advantage, we wouldn't have two different types. So what's the advantage? No, it don't. The gauge. What determines the ampacity is the gauge of the wire.
Okay, so it's
Huh?
solid wire sticker.
Yes, the big advantage of stranded wire is it's flexible. The biggest advantage of solid strand wire is that it's easier to terminate. Eventually, everything comes to an end. It's also easier to splice. So this is why in house wiring we use solid wire. Because why? One reason. It's easier to terminate and easier to splice. We just take it, we twist it together, and we put a wire nut on it. That's why we splice that. If we did that with stranded wire, it would spread out and burn cage and do all kinds of stuff. So stranded wire, we usually either solder it together or we use crimps on it. We usually don't crimp solid wire. We usually just twist it together, and we still solder it too. Wire shall be strain relief and must provide a slight loop to allow at least one fill repair. Now that's what really gets you, where people pull wires and make them exactly the right length, and they don't leave any room for what? Repair. And something happens, you got to replace that. Something happens, like something breaks, and what you got to do is you have to replace the whole wire. If you left enough room for one repair, you could do what? And that's even true in house wiring. House wiring, before you put that plug on there, you got to have 6 inches of wire from the outside edge of the box. And what's that in there for? Well, that's in there for so if something happens, you can do what? You can repair it, because that's where most of the damage occurs, is at the. So when a plug starts going bad, you get a bad connection, it'll heat up the wire and burn the insulation off a little bit. Well, if you've got one repair, you can cut that off and put a new one. And your house wire runs through your wall. If you got to replace house wiring, you're in big trouble. You usually figure out how to run it in the house. The wire insulation must be within 2 wire diameters of the solder joint, but not touching the solder. No bird caging beyond the diameter of the insulation. Bird caging only occurs with stranded wire. Bird caging is the tendency for when you twist it, it's a tendency for it to spread out. Usually frayed wiring is wire that's been frayed or scraped up against. That's usually the term we use there. Bird caging is the term. Of course, you get people that pick up on different things, but bird caging is when you take the solid strand wire, or even when you strip it. Stranded wire comes different ways. Of course, one of the biggest disadvantages of stranded wire is it's hard to terminate, but it costs more per feet because it's harder to make, right? You understand that? And then what they'll do is they have different methods. They can twist it. A lot of the small gauge wires, they just run them through there straight. So they'll come up, and as soon as you strip them off, they're going to do what? They're going to spread apart, and they bird cage. So you have to twist them together and that kind of stuff. Of course, what happens, a lot of people don't understand, even the stranded wire is made up of multiple solid strand wires. And the problem is, if you nick a solid strand wire, we call it scribing. You drop down you decrease the physical strength of the wire by quite a magnitude.
I got next up on what class you're supposed to do. And students coming in, I was like, you do another one.
Surprise.
So, this is a solid strand wire. And so a solid strand wire consists of one strand, right?
Yeah.
And of course, any metals, anything that's solid, if we come over and start bending it, eventually it's going to do what? Yeah, eventually it's going to break. As you can see, I hadn't been counting. It's pretty solid, right? What I'm going to do is I'm going to come over here and take my knife, and don't do this, guys, but I'm going to come up here and I'm going to strip it. And I'm going to strip it into it like this. And you see a lot of people doing this. And if they do this, and then we come over here and do this. And what I've done is I scribed the wire. And it took, what, 2 bends to break it.
A lot less.
Yeah, of course, I never got this one to break, but eventually it would. So that means if I come up here and strip this thing, if I nick this thing, so if I come over here and put this down like that and strike and do like that, I just nick that wire. Now I scribe the wire, so what's it going to do? Yeah. So normally what we do if we're going to strip these things with a knife, we do it away from us and we strip it at an angle. Can y'all see what I'm doing? And what we do here is now I'm not scribing the wire, I'm putting a little dent in the wire. And putting a little nipple in the wire is not going to hurt the wire. So you see how I strip this off, right? By the way, this is going to be on test. I'm going to sleep over that. So see, I stripped this wire with my knife. Plus, that's a lot safer because I'm slipping at this angle like this. U.S. Steel, if you was going to strip wire, you had to put it on a table like this. You couldn't hold it in your hand. But, so I stripped that. So the other time I scribed it. But this time, so see, it's got basically the same strength that it had before. So when you strip a wire with a blade like this, you strip it with an angle, right? You understand that? Another thing that's very, 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 very important. They're really neat. These are wire strippers, and they're also crimping tools, and they're also screw cutters or whatever. So you can actually trim different screws. That this gives you the screw size here, so you can cut them real neat, and they work out really, really well.
Yeah.
What we've got is, if you look down through here, it's got the gauge of the wire that each one of these blades are designed to strip.
Does it also say it's solid?
No, it doesn't make any difference, but the gauge of the wire is the diameter of the wire. So if you got a 22 gauge wire, a 22 gauge wire is a 22 gauge wire. Is that solid or is that strand?
Doesn't matter.
Doesn't matter.
It's weird. I have a pair of
It does.
yeah, I don't know why.
So this is, so what the normal tendency is people want to do things easy. And what they'll do is they'll come up here and use the wrong size because it strips easy. And what happens is they do what? They scribe the wire. And then of course when we scribe the wire, it makes it real easy to break. If you strip with the right gauge, these things are not easy to do. And avoid doing this too. Avoid coming over here and doing this. You understand? That makes it easier to strip, but it makes it more likelihood that you're going to cut through the insulation and do what? Scribe the wire. The right gauge, you probably have to pull it to the side like this and put it at an angle to actually come up and strip it, and it's not easy. And why do you want to put it at an angle? Is that if it does hit the wire, it's going to nipple the wire and not scribe it. And it's not easy to strip this thing. Now the actual limits. How many strands can you possibly lose in a solid strand wire? In a solid strand wire? Absolutely none. You only got one wire. Yeah, solid strand. So this is the list. This is the number of strands you could lose. If it's got less than 7, If it's got less than 7 strands, how many can you damage? None. Because these guys are going to be big and they're going to really determine the gauge of the wire. So every time in a stranded wire you lose a strand, what do you just do? You change the gauge of the wire. If you change the gauge of the wire, you change the ampacity of the wire, right? You understand that? So less than 7 to 15 strands, you can afford to lose 1, 16 to 18, 2, 19 to 25, you can afford to lose 3, 41 strands, you can afford to lose what? 6. A lot of people don't understand that, and they'll scribe it. They'll take it. They'll have a stranded wire. They'll strip it. They'll lose 4 or 5 strands off a stranded wire, and they go ahead and use it. What did they just do? They just changed the gauge of the wire. And if you change the gauge of the wire, you're changing the ampacity of the wire, right? You understand that?
Yeah.
Conductor prep. I need to go over there. I'd have to find my strippers. These are type of strippers that we used in the military, and I'll have to find them and show them to you. They're really neat. These are thermal strippers. These guys here are really nice. We used to have soldering stations that had the thermal strippers on them, but these literally melt the insulation. And what's nice about thermal strippers is there's no way in the world you're going to scribe the wire. Huh? Smell? Yeah. I know. What you're supposed to do, and it's real hard to do, is you're supposed to start scribing. If you got a stranded wire, you're supposed to come up here and don't break it off all the way. You're supposed to pull it out if it's stranded, and then twist the wires with the insulation instead of with your fingers. And why is that? Huh? Yeah, because we're very oily species, right? You understand? So you can just go over there right now and touch that glass over there, and what will you leave? And you'll leave a fingerprint, and it's actually basically nothing but oils, right? So one thing that we do before we are going to really do some good soldering, we go and wash our hands first, try to get the skin oil off of that. Of course, we want a nice clean cut. We don't want to fray it. We don't want to do anything like that. This is called bird caging. Bird caging on a stranded wire. The strands try to do what? They try to come apart. Yeah, it is. Wicking is when you tin the wire, when you tin it, and then the solder wicks up under the insulation. We want to avoid that. For one thing, you heat up the insulation, which means it changes the properties of the insulation. Plus, what it does is that you lose the biggest advantage of stranded wire, and that's just flexibility, right? Tinning is a process, so pour wetting. So that means anytime we have pour wetting, we refer to that as a cold solder. It is unacceptable. It means that one of two things: you had some type of impurity on the surface that the flux didn't clean off, or it means you didn't get the metals up to the right temperature to melt the solder. Huh? What is wetting is in soldering? Wetting is the term that we use when the molecules of the solder bond with the surface molecules of the metals being soldered together. So it doesn't. Well, you could have got here on time. You would. If you wouldn't have went to the wrong class, you would have. Huh?
It's annoying when it happens.
I know. I've never done anything like that. I showed up to U.S. Steel one time and I wasn't even supposed to be working.
That was very awkward.
Yeah, I was out there standing around. I went over and looked at the schedule. I said, Rich, you weren't supposed to be out here. Okay, let's look at some of the slides on putting on terminals. We have different types of terminals. So every conductor, what's the function of the conductor? The conductor has one function, and that's to get that current from the source to the load. That's it. That's its function in life. It's just like, what's the function of your blood vessels? Blood to your muscles, right? Y'all understand, they have one function in life, and that's all they do. Just bring it out and get it back. So the process of eventually every conductor comes to an end. The process of bringing a conductor to its end is called termination. And of course, we can't have, sometimes we get wires that break, sometimes we run out of wire and we have to put two wires together. The process of joining two wires together, two conductors together, is called splicing. So we teach a class called cable splicing and termination, which we teach all of this. Or you'll get an opportunity in that class to actually do this, where you actually terminate and splice conductors. This class is primarily going to be dealing with just basic soldering of stuff on a printed circuit board. So that's what we'll do right now. We'll get into this. Who's not here? James sent me an email that says he wasn't going to make it. Kamir sent me an email saying he had to cover for somebody at work this week. No, he said 2 people quit. They didn't give a notice.
Oh, that's recent.
So what we're going to be putting together is that y'all solder and put together a robot, and you won't be doing any soldering in conductors, but if you do take the cable splicing and termination, this gives you all the rules and that stuff. So what we're going to look at here is installing components. So this is our kit that we're going to be putting together, and it's an escape robot. And of course, you're going to have the process of putting parts in a circuit board are called loading. So you're going to load the board. This is what we call a single-sided circuit board, which means there's no traces on one side of the board. A double-side circuit board would have conductors not only on the bottom but also on the top. And then we literally have multi-layer boards, which basically has conductors through the center of the board. A lot of your what we call motherboards that are made in computers, those are multi-layer boards. So we call this a single-sided board because we only have conductors on one side. We refer to these on printed circuit boards, we refer to these conductors as traces. Also, some people call them foils because they look a lot like aluminum foil. Then what we have is we have exposed parts. These little things are called solder eyes because they kind of look like eyes. So this is the side of the board that we're going to solder on. Also, what we're going to do here, on most single-sided boards, your components only mount on one side, and then you solder on the other side. We're not going to deal with any surface mount soldering here. That's very complex. So all the components we're going to do here are referred to as through the hole or through the board. So they have pins on them, and they literally go through the board. Okay, you'll understand that. And then what we did is we have the components. So this is the little controller chip that takes care of controlling the robot. Now what they do here is they're going to mount this in what we call a socket. So We do have sockets for different devices. We have sockets for transistors. We have sockets for printed circuit boards. I'm sorry, for integrated circuits. So this is actually an integrated circuit. So what we're going to do is, and what's nice about these is it makes it easier to repair, because if this integrated circuit goes out, you wouldn't have to install it. All you have to do is just pop it out of the circuit. And also it makes it a lot safer, because there's no way in the world you're going to damage your controller chip with heat, because it's not going to be in there when you do what? When you solve it. What else we're going to get with the kit is you're going to get an inventory, and then of course you're going to get a procedure for constructing it, right? Now, what you're going to do is you're going to build the gear train at home, and you're going to do your soldering here on your kit. Everybody will get a kit.
We go through the process. Are we able to kind of build that products?
Yeah, that's what you do. Normally, basically, it's a technique that you learn. A lot of people, I've seen people try to load everything on there and then come back and solder everything. To me, that gets real hard, because you got so many leads sticking up in the air, they start getting out of the way. My preferred method is to load several components, solder them, clip them, check them, then load some more, clip them, check them, and then some people do one at a time. And it's all a preference. That doesn't make any difference which way you do it. I just wouldn't recommend that you solder everything, try to put them all in there. This gives you a lot of information that y'all should know. It tells you about the resistors, and then it comes in and gives you the color code, but you should know that, and it tells you how many pieces you're supposed to have. And then you'll get a couple of bags. This is the I'm not going to take these out yet. This is the photo transistor. So what this thing has got, it's got 3 infrared LEDs, light emitting diodes, and they're set off at an angle. You got one that points straight forward, and you got 2 that point at about a 45-degree angle. And what the controller does is it pulses one, and then looks for a reflection. It'll pulse this one, it'll look for a reflection, and then it'll pulse this and look for a reflection. So if it pulses this one and sees a reflection, it knows something's up against this side, and the thing will do what? It'll know, the controller knows which way to turn. And you can't see those LEDs flashing because it's infrared. And you can't see infrared because it's out of our eyes can't pick up infrared. We just don't, the cones are what picks up colors, and then the rods picks up shades of gray. So even our eyes work basically like dot metric or inkjet printers. Huh? This is the actual schematic, guys. Of course, we don't have time to get over that in this class, but they give you the entire schematic of this, and this would be the controller. It's got 2 motors, and it controls the motors using what most people refer to as an H-breeze, but we won't get into that either. But this tells us how to assemble it. Now, what you need to do, if I can get the parts, how we do it, is that what we're trying to do is we're trying to not only do this thing and do the right soldering, but we're trying to make it look like it was put together by a machine. So that means all your resistors need to be oriented, so every resistor points this way needs to be oriented the same way. Every component that's not color coded, that's got to be a value, you need to make sure you rotate them so the values can be read, right? Y'all understand that? If you've ever worked on a printed circuit board, one of the most discouraging things is for people just to stick things in there, and you got to replace a part, and you can't read part number. Because why? They mounted it down. It's just a rigid circuit board. We don't have any flexible. They do have flexible circuit boards, but but, probably an optical illusion.
Yeah, I see it. That's the speed of the camera.
Yeah, this is a very low speed. I need to probably go get my other camera. So, huh?
I was saying that.
Yeah, I can. Of course, y'all should know color codes. It should give you the capacitors. It's got transistors in it, but we'll mount some resistors so I can show you how to do that. So we're looking for R18. So let's see what R is. Let's find R. So what they normally do, you can see this is called silk screening, basically, where they paint all the items on here. Of course, resistors have no polarity. They can be mounted any way, right? All we want you to do is mount everything in the same direction. So that means in center them on the mount as soon as I get my finger in here. And I'll show you how to do that in a minute. Oh, here's the way. Here's the camera. Here we go. So that means, you know how resistors are laid out. These are I think these are all 4-band resistors. So I'll have 3 that enters the color code, and then 1 would be the tolerance. Well, if we're going to put them all in the same direction, then we'll make sure the tolerance band is always on the same side. You don't keep flopping those things around, right? So here's R18 right here. And it says R18 is supposed to be a 100 ohm resistor. So what's the color code on a 100 ohm resistor? Brown, black, brown. Good. So here's the 100 ohm resistor. And what we got is we got these little needle nose pliers right here. And what we're going to do is we're going to come over here and we're going to take this, and what was R18 at? Right here. So once I figure out how I'm going to mount these color codes, and basically what you're going to do is you're going to lay it on there and you're going to move your needle nose pliers. Now what you want to do on your resistors is you want to put your needle nose pliers between where you're going to bend it at and the actual resistor itself. Y'all understand that? Because you want to leave that L shape in there, because what happens when resistors get hot is they expand, and what happens when they cool down, right? You understand that? And if you tighten down these leads and you pull them tight, then over time they'll literally pull themselves out of the resistor. So what I'm going to do is I'm going to come over here and I've marked it, and then I'm going to take my finger as soon as I get it under here, and then I'm going to bend it down. I'm going to bend it down at 90 degrees, right? You understand? Then I'll come over here and do what? Bend the other side. Y'all see that? And then what will I do? Then we'll come over here and okay. Then we'll come over here and we'll insert it. I'll try to. It's hard to solder on the camera. Okay, now the next thing you're going to do is you're going to flip this over and you're going to bend these leads out a little bit. Can you see what I'm doing? Now why are we doing that? Well, now I can let go of it. If I bend it out a little bit, then now my leads are going to hold the component in there, right? So what I did is I held pressure on it. These resistors, these are 1/4 watt resistors, and they can be mounted flush with the board. It's only when you start getting up to like 1 watt resistors where you've got to leave a space under the resistor. So anything up to a watt, you literally mount those resistors flush on the board. Okay? Y'all understand that? Okay, guys, y'all take a break, because guess what? Yeah. It's a preference. Why would you wear gloves? I mean, no, it's not mercury. This is lead and tin. Yeah. Well, lead, the molecules of lead are so big people don't get in trouble with handling lead. They get in trouble with eating lead. So don't stick it in your mouth, right? I remember a long time ago before we had that, and that might be what's wrong with me now. When I needed 3 hands, I'd literally put the solder in my mouth, solder like that, but I don't do that. Of course, if you've got cuts on your fingers, you need to wear gloves or something. But if you don't have cuts on your fingers, then solder is not going to come into your skin come into you through your skin like mercury will. Now, mercury is what's dangerous because its molecules are so small, it'll actually do what? It'll absorb through your skin. So mercury is really dangerous. But lead is not dangerous as long as you have no cut on your hands. Then you don't need to wear gloves. If you do have cuts, then you need to what? You need to wear gloves and keep it out of your mouth, right? Wash your hands. Don't use this disinfectant. All you do is the lead is still there. All you're going to do is just spread it around. When you get through soldering, what should you do? Wash your hands. Wash it really good with soap and water. Okay? And you'll be fine. No problem at all. Right? Because I've been handling solder. Another thing, of course, you're going to have to touch it. We use these things a lot too. When I use mine, you'll say this is the way I'll do it because I can control the flow of the solder a lot better. Plus, we use a real small gauge solder. I don't remember what this is. A lot of people like big gauge solder but I don't because it's harder to control the flow. This guy, a real small gauge solder, you can control how much solder that you use. And one of the biggest problems people have is using too much solder. So what we're doing is we're looking for this wicking effect. And we're trying to look for that what? Might be. I can't remember what the gauges is. We buy the same gauge all the time, and it's really good gauge for what we do. So that way you're not feeding 300 feet of solder. So what we're looking for is we're looking for wetting. And wetting is the binding of the surface molecules with the solid, right? Well, if I'm doing this, if I'm fixing to do this, so I've got this solder eye right here. Okay. And I've got my lead coming through, and then I've got it bent back like this, right? Well, what I'm trying to do is I'm trying to get this right here. And I'm trying to see where it actually merges with the eye and it merges with the lead. If I can see that merge, then I know I've got wetting. Well, what usually happens is people will come up here and they'll come over here and they'll end up with something like this. Now, what's the problem? And then my lead is in here somewhere. Well, what's the problem with that? Well, see, it might be a good joint, but what? Might. This is a good solder joint. This one, I don't know. So if you can't tell if it's good, you assume it's what? Bad. Okay. So what we need to do is we need to come over here and I'll show y'all I got one joint I need to redo. Huh? Oh, yeah. But what you need to do to get wetting is you got to get both metals up to the right temperature. So we come up here, we pick it up, we tin it, come down here, put it, touch both metals, come here on the opposite side, and I'm through. Come over here, heat it, touch both metals, and we solder on the opposite side, and I'm through. And then what I do, then I'll come up here and I'll clip the lead up. Of course, you should have safety glasses on there. You put my safety glasses on. And what you need to do is try to hold the leads when you clip them. Because if you don't, when you clip these solid metals, what's going to happen? A lot of times it'll just do what? It'll shoot off. So anybody want to come see this? In fact, let's do that. Real fast, right?
Yes.
Yeah, I'm supposed to. Not much solder at all. If it don't start instantly, touch the iron and then move to the other side. But always end up soldering on the other side, right?
Yeah. If you want the solder to pull over to probably the entire pad and connection.
And of course, that transfer between your soldering iron and the board is done with that tin. So that's why it's very important that you tin.
I just came with my own stuff.
We do have some things that normally we don't do in soldering. For one thing, but we have to do it on this thing. It's just the way it's put together. There's one thing when you mount this photoelectric cell. So this is your photo transistor. I'm sorry. And then I'm looking for a little circuit board. Okay, where's it at? Oh, here it is. So this is the photoelectric cell. And what we're going to do is, let me make sure which one this is. Make sure I put it in the right direction. Because that goes like this. Goes like that. So I mean, this is going to go in there like this.
Oh.
So what we're going to do, or what you're going to do, is we'll take, let's solve it. We're going to take this and we're going to tin the board.
The whole board or just tacks?
Could tack it.
It's like welding. Stick welding.
You can see how far this is from there. Because you want this to be flush, so it looks like it's going to come almost all the way down.
It looks somewhere in the engineer.
And then what we're going to do is once we get this done, and then we should be able to come over here and do what?
Tap that guy out.
Just tack that on. Okay, you'll see that. I'm not getting in a hurry because I'm going to start on these. Okay. Now, once you get it on there, of course you need to take it all the way up, right? You understand that?
Thank you.
Now what you're going to have to do here, normally we don't bridge solder, but this is where you're going to have to do that. When you mount this in here, you're literally going to have to bridge this gap right here. See that? Yeah. So you got to bridge that gap with solder.
Oh, that's a very unique way of doing it.
So we got to bridge over here. I can see.
You're still in training, bro. Ah,
Y'all see, that's all I want to do. But y'all see what y'all got to do? So you got to really bridge the gap. So you got to make a solder between there and there. So you're creating what we call a solder bridge. Normally we don't like solder bridges. That's a big problem. People get over here and they'll get their iron and they'll actually bridge across. But that's what you got to do there. Now the transistors are pretty easy. And this is, and I don't know why people do that. Can you see the way the transistors are shaped?
They're shaped like these. Like
Yeah, these are, we call these a TL92 transistor outline number 92. And can y'all see the dang thing? They're in the shape of a D if you look at them from the top.
And yet people put them in back.
Put them in backwards all the time. All the time. Not just every once in a while, but all the time. I just dropped the screw.
You can't have that.
Yeah, especially since
You're gonna wheel into it and then it's gonna be stuck on your wheelchair and you won't be able to find it.
okay, So first of all, this thing's got a number on it. So we got two types. We got NPNs and PNPs, and they are not the same.
No.
So you just can't randomly insert these things in there, right? You understand?
Follow the deal
So
in.
this right here is looks like a 4050. So when we come up here and look, it's going to tell us where these things go. There's our transistor part C. So here's, by the way, the designators for the silk screen designator, we can't use T because T was assigned to transformers. So what they do is they started using other letters of the alphabet. Like integrated circuits, this is very uncommon. They call it IC. Normally what they do is they call it U, U1, U2, U3. Normally what we try to do on these designators is we try to give it a single letter to designate what it is. Okay. So transistors are designated Q. The Q. And this right here, it says, okay, this transistor right here is this is an 8050. So that's this guy right here, 8050. So we'll use these for Q1, Q2, Q3, Q4, Q9, 10, 11, 12, right? Okay. And it's going to be silk screen on here. So this is an 8050. So let's find Q1. Here's Q1 right here. It's in the shape of a D, right? You understand? So all we have to do is just come up here and do put it in. These you don't want to go flush. You want to leave these up. In fact, they got little plateaus in them, so they won't insert further than they're supposed to go down. Come up and just bend two pins out right like that. You don't have to bend the center one out, right? And now what it'll do, hold itself in there, and we do the same. So now we're down to soldering just like we've soldered everything. And I think that's about it, guys. So, I need to show you one more thing. Where people mess up. Good gracious.
Where's that?
I'll show you. We'll show you one put together. Got a little too much solder on there, guys. By the way, if you get too much solder, which means it bubbles out. So if you look at this, I got a little too much solder on that. So instead of looking like a volcano, it looks like a bubble. That's too much solder. What you can do is just don't pin your gun, don't pin your soldering iron. Come up and clean the solder off, and then you come over here and touch that, and it will pin your iron and wick off your iron. So that's one way you can do it. Another way you can do it is use what we call a solder back. Now, what's nice about solder is you can re-solder, you can heat it up and cool it down, I think up to like 15 or 20 times before it actually starts hardening on you. But what we do on a solder back is we come over here, and what you got to do is you got to keep, this is a Teflon tip, it will not melt. And we got to come over here, and we got to come up here and actually put it down on it, and then suck it out. Ain't that the neatest thing?
What's the disadvantage of having too much solder in it?
The disadvantage of having too much solder is you cannot tell it's a good joint. If you cannot tell it's a good solder joint, you assume it's bad.
That's the only.
I understand.
That's a waste.
Huh?
True. Especially with ICs.
Yeah. So if it's got that bubble on it, you cannot tell it's a good joint. And that would be like guessing, like we talked about the other night, guessing putting air in your tire. If you don't put a gauge on there, you don't know if it's right. If you overinflate it, what'll happen? You could, or it'll wear out faster. If you underinflate it, it'll wear out faster. If you underinflate it, it gets hotter faster, right? So if you don't check the pressure, then that's the same way. So I don't know the air pressure's right unless I do what? Okay. Got one more thing to show y'all, and then we'll go get the kits and put y'all to work.
Good.
Now, normally we we require the students to buy the kits, but we got a whole bunch of them in there.
So we'll take these home.
When you're through, you get to take it home. You're going to go ahead, you're going to take the gearbox home. So this is the actual gear train right here. And the gear train, but there's something you'll have to do before you do the gear train. DC motors are very noisy, and we got an electronic circuit here. So what we do is y'all have to do this here, because all your soldering is going to be here. And what you have to do to filter it out is we put a 0.1 microfarad capacitor across the motor. And go ahead and install the wires on it. We'll go ahead and do that tonight, and then that way you can assemble the old gearbox at the house, right? Or the gear train. But we'll do the soldering of the circuit board and everything here. Let me put this up. Another thing people puts in wrong all the time is I won't do it, but I'll show you what they do.
The dial or the capacitor?
These guys. So notice these are the infrared LEDs. So this is a photo transistor. So what this thing does, what the controller does, is it'll turn on this one and look for reflection. If it don't see any reflection, then it'll turn on this one, see if it sees reflection. So if it sees reflection off this one, it knows it's up against something, it'll know which way to turn, right? If it comes up and sees this one, it'll literally back up and turn, which is pretty neat. What people do is I've seen them, they'll come over and solder the LEDs point. They won't put the little base on there. They'll solder the LEDs point straight up in there. And then they clip the leads off on it. Well, if they clip the leads off, well, they're not long enough to put the mounts back in there because the leads now are real short. So can you see what happens? You're going to mount these in there. Now these are polarized. So you notice right here it's got K. See K for cathode? And it's going to tell you how to do that. So if you read instructions, you won't get any trouble. But we've talked about this in this class before. But there's two ways of identifying the cathode. One way, before you cut off the leads, is it's the shortest lead. The other way is the cathode. If you look at the lens, it's got a little loop around the bottom, and it's got a flat side. So we got two ways of identifying these. So the first thing you'll do is what? Where's the mounts at? And we have people that mess up on this all the time. This is the battery connector. Another thing, and this is polarized. So this is another thing they'll do. They'll do what?
Put it in back.
They'll put it in backwards. Okay, so look, everybody look. So look, y'all look. So here's the battery connector. And can you see the three dashes across the front right here? If you look at it front, see the three dashes right there? So this will what? Go in there like that. If you put it like in there like that, then the battery, you're going to put the wrong polarity on that thing. Are you okay there? I'm looking for the mounts for the LEDs. And then you'll do what? This one, unfortunately, these pins are too hard to bend, so don't break your fingernails on them, right? So what you'll probably need to do here is put this up against some type of surface to solder it so it won't fall out. See, because you can't bend those pins without breaking your mind. So what you need to do on these is you need to do what first? So these are going to mount in here. You can see what happens. See the two holes right there? And they're going to mount in here. But what you're going to have to make sure you do first is make sure you put the cathode on the right side. So see the K right there? Okay, so before I put it in here, I'm going to do what? Put the short side on there, right? And then what I'm going to do? Then I'm going to bend them down. Then I'm going to do what? Insert them in there.
What's the K stand for?
That stands for cathode. They don't want to call it a C because of these guys right here. So capacitors are given the C designator. So,
industry standard.
that's why the cathode on LEDs, they give it the K designator. So like I said, which makes sense, it just not spelled right. So notice I bend it over, solder it wide, the same way. But this guy's gonna mount, I said 45, but it looks like it's around 30 degrees. This guy's gonna mount straight forward, and notice they give you the arrows, right? And of course, what do people do? They'll stick those LEDs and point them straight up, and then they'll clip the leads, and now they can't do what? Then we'll end up soldering extra leads on there.
So they would do it upside down?
No, they'll come up here and do this. They won't put the mount on there. And they'll come over here and they won't be following the instructions. And they'll come over here and they'll take the LEDs and put it right into the printed circuit board like this. And point them straight up in the air. Right? And then they'll solder them and then they'll do what? Then they'll clip the leads. And then they'll note it, they find out they do something wrong, they'll unsolder it, and then they can't get it in this long because now the leads are not. So we found leads that's cut off and splice them on there by soldering them. Sometimes we can get them back in. What else? One more thing before we start. The post. This is the other problem people mess up on all the time. They'll come over here and they insert these posts in here. Can y'all see that?
That's itty bitty.
Oh, can you see that plateau on there?
Yeah.
And what do you think they do? They come over here and put them in the bottom like that. And that's not the way they go. They come into the top. Just like that. Right?
Short side now.
Yeah, and then they don't have enough. Then they don't have enough to put the motor connectors on there.
That's sad. That's a sad.
So these don't come in from the bottom. And then plus, I don't know if that's. So guys, I think y'all about ready. Anything else I wanted to tell y'all? Watch out, the speaker, the little beeping speaker right here, this is polarized too. Y'all see that? It's got a plus on it. And if you look at the speaker, it's got a what? Plus on it. You see the plus? The plus disappears when you pull that tab off there. So what does that mean?
Don't pull the tab off.
Mount it and then pull the tab off. See the plus right there? See the plus right there? Another thing, where's the one put together? This is, we'll end up with all 6 wheels on there, by the way. The screw in the plastic. Another big problem we have is people think they got to torque it down to 500 psi and they break the plastic, right? You understand that? These are the little capacitors that we were talking about. These have to be mounted on there. You're going to have to mount those on there tonight. And of course, you can see the motor connections. Probably one of the hardest things to do is to get these wires inside those little yellow tubes. This is a single pole double throw. It don't make any difference which way you mount that in there. It works the same way each way.
So you don't care how we put it in.
Okay. Make sure this LED, this is the power LED. This one will probably work if we ain't got some batteries. And we'll have this one out that you can kind of use as a reference. So you see the gear train on this is pretty interesting. So the motors come in the side. It's got a very small one, goes to a big, goes to a little, goes to a big. Right? You understand that? Goes to a little, goes to a big. So we're going to get a pretty good gear reduction on this thing. And like I said, we'll leave this out to show y'all. This is the project that I did. Nancy decided she wanted
But it wasn't a big 7.7, so you told me I could have got some massive. 4 board, huh? Yeah.
That big?
Bigger than that.
And so this is what I did. This is my song. So you think about that, that's 12 LEDs per segment in it, 7 segments.
Aren't you proud of yourself?
I am.
Our new board.
That's one of them.
So what are those for?
Just to show people 7 segment displays. One of the things that they did, we noticed on the Siemens certification, I think it was level 2 or level 2, is they require just to know that. And what we realize is that we're going to teach the digital that they require is not really in depth. So we're going to teach the digital as part, the digital that's required for the test as part of motor. I mean, not part of PLCs. But then we realize that they require you to know a lot about these things.
So we're gonna try to add this to this.
So we're going to show them
Level 2.
what a
Intro
7
in
segment.
advance.
Huh?
Intro or advance.
Intro.
I can't wait for
Advanced